So we continue our adventure in solving logarithmic equations, and we're going to see some variety in that work. We've got an exploration statement where Alice has started doing some work, and we've got to complete it for her. So I need to FOIL that out. That's x squared minus 3x plus 1x minus 3 is equal to 5, which is x squared minus 2x, and then the 5 moves over so that I have minus 8 being equal to 0. And now I've got a polynomial that's equal to 0. I get to factor that. That's x minus 4 and x plus 2 being equal to 0, which means I'm suggesting that the answer is either 4 or negative 2. But I've got to check that out. So I'm going to go back to my original equation and plug in and see if both are true or if one doesn't work. So I plugged in x equals 4, and that seems to satisfy the equation because I can take log base 5 of 5 and log base 5 of 1 and actually generate the answer. Now I'm going to try negative 2. So in this case, x can only equal 4, and x equals minus 2 is called an extraneous root. It has no bearing in our work, an extraneous root or an extra answer. Let's turn the page over. So here we've got a log rule we get to try out. 2 log x equals log 16. Now I can get the logs together. So 2 equals log base 16 over log x. Actually, since the logs are the same, we can simply say that x squared is equal to 16 and x equals plus or minus 4. Remember, we've kind of got a problem with negatives, but in this case, negative is possible. On the other side, where I have a similar statement, I can move the 2 back to the exponent position, so log x squared equals log 16. And here again, x squared is equal to 16. X equals plus or minus 4. But in this case, I have trouble because the original equation does not actually allow me to take the log of negative 4. That's not possible. So the only answer here is x equals plus 4. And remember the difference in these graphs. Remember, this was from our last unit where we saw that x squared log graphs were a little bit different. So when we take a look at those log graphs, the graph on this side comes through at 4, but I get a mirror image on the other side at negative 4 and 4 because the original graph allows me to use both 4 and negative 4. So we have 2 examples to do, one with a minus and one with a plus. Remember, when logs are being subtracted, you can write it as a single log. So log base 4 of x plus 1 divide by 2x minus 3. Equals log base 4 of 8. Now I have single logs on both sides, so I get to say that x plus 1 over 2x minus 3 is equal to 8. X plus 1 is equal to 8 times 2x minus 3. Do a little bit of manipulation. 16x minus 24 is equal to x plus 1. Subtract the 1x over, that's 15x. Add 24 is equal to 25. X is equal to 25 over 15. And we'll solve on the other side as well. I think I'm going to leave the 1 on the right-hand side and move the log base 6 of x plus 4 plus log base 6 of x plus 3. So a single log, that's multiply log 6x plus 4 times x plus 3 equals log base 6 of 1. I can drop my logs and then proceed with the multiplication. So I actually needed a log statement on that right-hand side. 1 can be replaced by log base 6 of 6. Then I can drop the log statements. Then I get to set up for factoring. So here I get x plus 6 and x plus 1 to be my factored statements, which means x equals minus 6 or x equals minus 1. Now I'm to the point where I have to go back and check those answers. So now we actually have to go back into these two questions and see if our answer is actually valid. It's called proving whether your answer is valid or not. And I'll do this one first. So 5 over 3 was equal to x. So what I'm supposed to do is evaluate log of 5 over 3 plus 1 minus log of 2 times 5 over 3, log base 2. Of 2 times 5 over 3 minus 3. And actually see if that's equal to log base 4 of 8. So that's my question. We're generally looking to prove, is the left side equal to the right side? So left side and right side. And we want those to be equal to each other. So in plugging in 5 over 3 for x, I got 5 over 3 plus 1. That's 5 over 3 plus 3 over 3, which is 8 over 3, minus log base 2 of 10 over 3 minus 3 over 3. So that's 10 over 3 minus 3 over 1, pardon me, 10 over 3 minus 9 over 1. That's 1 over 3, which I can consolidate to 1 log, and it's in fact equal to 8. Now I want to take a look over here with x being minus 6 or x being minus 1. I see quite quickly that minus 6 is going to be a problem. Do you see why minus 6 is a problem? Minus 6 is going to cause me to have to take the log of a negative number, which I cannot do. So I'll take a look at proving that 1 actually works. So I've run my x equals minus 1 into my original statement and just trying to keep the left-hand side and the right-hand side separated. So the left-hand side simplifies to log base 6 of 3. The right-hand side, after a little bit of work, also becomes log base 6 of 3 as well. Left-hand side equals right-hand side, so I'm done. So that's it for lesson 4. We've got one more lesson to practice with or deal with on Wednesday, and then we'll save the practice test and the quizzes for after teachers convention. I know that the next 2 days are busy enough for you, so do what you need to do after these lessons are presented. Thank you.